Good morning, grade 9. How are you doing today? Hope you are fine. We're going to continue today lesson that we have started yesterday, solving radical equations and inequalities, chapter 5, lesson 8 in algebra 2. Yesterday we have learned how to solve radical equations. We have some steps we have to follow. The first step is to isolate the radical. Then we have to raise both sides of the equations to the power equal to the index of the radical. Then we have to simplify and solve. This if we have one radical in one side. What if we have two radicals in two sides? We have to square both sides. What if we have a cubic root? We're going to raise both sides to the power of the index of the root. If we have cubic roots, we're going to raise both sides to the power of the index of the root. Today we're going to solve equations with extraneous solutions. Okay. Extraneous solutions that make the functions or the equations incorrect. So, solving equations with extraneous solutions, solve square root of x plus 18 is equal to x minus 18. Okay, and the first method is use a graphing calculator. We're going to use a graph calculator to get the answer. And method 2, we're going to solve it algebraically. Okay, solve for x. Okay, square both sides because I have here a square root. So the first step was to isolate. It's already isolated. The second step is to raise both sides to the power of the index of the root, which is 2. So I raised both sides to the power of 2. Then power of 2 will cancel the square root. Then I will get x plus 18 is equal to, I will factor x squared minus 4x plus 4. So I will collect all the like terms together and I will give equal to 0. I will write them equal to 0. Then I will give the values of x. X is equal to -2 and x is equal to 7. Step 2. Use substitution to check for extraneous solutions. I have two values for x. X is equal to -2 and x is equal to 7. So use substitution to check for extraneous solutions. Okay, when I substitute for x is equal to -2, what I will get? -2 plus 18, so x is equal to square root of 16. So square root of 16 will give me x is equal -2 plus 18, so square root of 16. So it will be here 4. And in the other side, if I am going to substitute x by -2, -2 is -4. So in one side I have 4 and in the other side I have -4. So it is wrong because I must have in the two sides equal numbers. So x is equal to -4 is wrong. Okay, so it is extraneous. Extraneous. It makes the equation wrong. So let me try the 7. 7, I'm going to substitute x by 7. 7 plus 18 is 25. Square root of 25 is 5. So in one side I got 5. Let me substitute in the other side x. By 7. 7 minus 2 is 5. So I got in the other side 5. So in the two sides I got the same number. So 5 is correct because it makes the equation correct. Because x is equal to -2 is extraneous, the only solution is x equals 7. So I cannot stop after step 1. I cannot stop after step 1 because I have to check my answer by substitution, because I want to know where is the extraneous answer, because one of them can make the equation wrong, can make it undefined. So really, -2 is wrong. So I have to make step 2 continue till step 2 to get the extraneous answer. Let's watch together this video.
All right, let's take a look at another example together. This one has some square roots and some non-square roots. Check it out. Square root of x plus 17 equals x minus 3. What do you do? Well, I'm going to square both sides because I want to undo that square root there. So we're going to start off by squaring both sides and hope for the best. So I'll square the left. That will lift the radical. Square the right. That will involve a FOIL. So on the left, that's pretty easy. I just get x plus 17. On the right, here's a great place to make a mistake. You could say x squared, plus 9 or something. But don't forget, you get a FOIL. So we get x squared. Then we have an outside, inside. That's going to give us a -6x plus 9. So don't forget about that term. Great place to make a mistake. Let's bring everything over to the right-hand side, just for fun. So I've got 0. So I'm going to subtract x from both sides and then subtract 17 from both sides. So I'll see 0 equals, I got the x squared. If I subtract an x from both sides, I'm going to see -6x minus another x. That's going to be minus 7x. Subtract 17 from both sides. So I have 9 minus 17, which is -8. And that all equals 0. Remember, if you're going to factor, you want everything to equal 0, so that when you have a product of things, one of them has to be 0. Does this factor? Oh boy, I hope so. Signs are opposite. 8 and 1 works. So therefore, either this equals 0, which means x equals 8, or this equals 0, which means x equals -1. Cool. All right, so we have 2 answers. And now we have to check them. So let's check these things and see how we make out. So we'll do our check. Check, please. All right, let's start with the 8. So x equals 8, check. We're going to plug it into the original thing, not to any intermediate stuff that you generated, but the original one. So we have square root of 8 plus 17. So that's the square root of 25, which equals 5. And what do I get on this side? If I put an 8 in here, I see 8 minus 3, which equals 5. So it checks. So it's good. So this is a good answer. Good. What about the x equals -1? Let's check that. Here I've got square root of, put a -1 in here. -1 plus 17 is going to be 16. Square root of 16 is 4. And does that equal, when I put in a -1 here, -1 minus 3 is -4. Aha. No, this is not equal. This does not check. And in fact, we see this is not a solution. This is actually an extraneous root, extraneous solution. There's only one. And you can see the power of checking. Now, you can actually check this answer for yourself by graphing this on a graphing calculator. So here's how you could try to solve this on a graphing calculator. Let me talk through this just really fast. What you would do is you would let the y1 function be the square root. So you would type in y1 equals square root x plus 17. And then enter for the y2 function x minus 3. And then what you want to do is you want to graph them both. And the question is, when you graph them both, how many places do they intersect? because the points of intersection are going to be the points where they're equal. Well, check it out. You see, they only intersect at one point, and that point happens to be seems to be around 8, and that's the point we found here. Notice they do not intersect anywhere else, and that's why there's only one solution, not the potential 2. Whenever you are solving an equation that's a radical equation, has square roots, or any kind of root for that matter, you've always got to check your answer, because you might have introduced a solution that's not really a solution.
Okay, going back to our book. Next page. Okay. Solving equations with the rational exponents. You can use similar methods to solve equations containing rational exponents. You raise both sides of the equation to reciprocals of the exponent. You can also rewrite any expressions with rational exponents in radical form and solve as you would other radical equations. How are we going to do this? Solve each equation. 3x minus 1 to the power of 1 over 5 is equal to 2. If I want to write this in the radical form, how I'm going to do this? As I have here a fraction, if I want to rewrite it as radical, the denominator is the index and the numerator is what? The numerator is the power for the whole term. So if I want to rewrite again as radical, if I have a fraction exponent here as a fraction, the denominator I will rewrite it as the index of the radical, and the numerator I'm going to write it as the exponent of the whole term. Since it is 1, so no need to write it. So 5 here is the denominator, so I'm going to write the radical sign and write the index as 5. Okay, then again rewrite or repeat the steps. Raise both sides to the 5th power. So why to the 5th power? Because the index here is the 5th power. Okay, the index here is 5. So both sides here are to the 5th power. 5th power here cancel the index for this radical, and 2 to the power 5 is 32. Add 1 here and add 1 here, so 3x is equal to 33, so x is equal to 11. So what is the extra step that we did here is this part. That we rewrite the equation as in radical form. I have exponent in a fraction form, so I take the denominator and write it as the index of the radical. I take the denominator of the fraction of the exponent and I write it as the index of the radical. Then I start to do all the steps that we learned from the beginning of this lesson. Okay, another example here. X is equal to x plus 12 to the power of half. Solve for x. Okay, what I'm going to do here, raise both sides to the reciprocal power. What I'm going to do, I'm going to Something went wrong here. Let me. Okay, I'm back. Okay, I'm going to do again. Raise here, rewrite as a radical form, x plus 12 to the square root, the denominator here. I will write it for you. X plus 12. Then I'm going to raise both sides to the power of 2. Then the power of 2 will cancel this radical. Then I will get this step. X squared is equal to x plus 12. Then I'm going to collect all the x's in one side and to make all the equation that I used to have, and the other side is 0. X squared minus x minus 12. So I will ask myself which two factors, when I'm going to multiply, they will give me negative 12. And when I'm going to add, they will give me the middle term, which is negative x here. So they are positive 3 and negative 4. So I have here x as negative 3 and x as 4. So I have to check for the extraneous solutions. So I will check here for negative 3. When I check here for negative 3, the two sides are not equal. When I check here for 4, the two sides are equal. That's why checking for and substitution is so important to get the extraneous answer. Let's watch together this one.
Sometimes an equation might not have a radical in it, and yet is a radical equation. Here you go. 10x minus 9 quantity to the 1/4 exponent equals 3. Well, remember, 1/4 is the same thing as the 4th root. So really, this is a radical equation in disguise. All right, well, how do you solve it? Well, it's easy because we know the laws of exponents. If I just raise each side to the 4th power, 4th exponent and the 1/4 exponent will cancel. Let's have an exponent of 1. So the thing to do here is pretty straightforward. I'm going to take the 10x minus 9 to the 1/4 equals 3, and I'm going to raise both sides to the 4th power. Here, this simplifies. I take the product and just get 1. And so I just am left with 10x minus 9. And if I take 3 and raise to the 4th power, that's 3 times 3, which is 9, times 3 is 27, times 9, 3 times 3 is 9, times 3 is 27, times 3 again is 81. Now if I add 9 to both sides, I see 10x equals 90, and so therefore x equals 90 divided by 10, if I divide both sides by 10, and so I see just 9. So there's our candidate, but we've got to check our answer to make sure this is really okay. And so if I put in a 9 here, then I see 90. 90 minus 9 is going to be 81. So I have 81 to the 1/4 power, which equals the 4th root of 81. What's the 4th root of 81? Well, that works out to be 3, which equals the right-hand side 3. And so this does check. So you can see x equals 9 is actually a correct answer. Let's try one more together. One more. Here we see x's on both sides. And on this side, the 1/2 exponent is really what kind of root? It's that's right, it's a square root. So I'm going to raise both sides to the exponent 2. I'm going to square both sides. And if I do that, in fact, I'm going to do that now in one step. I'm going to square this side and see x squared. And when I square this side, the 2 exponent and the 1/2 exponent cancel, and I'm just left with x plus 6. Haul everything over to the left because I see a square I want to factor, have everything equal to 0. And let's see, oh boy, I hope this can factor. This tells me they're different signs. Got to be a product of 6. And so I think that works. X minus 3 equals 0. That means x equals 3. X plus 2 equals 0. That means that x equals negative 2. Are these all good to go? I don't know. We got to check. So let's check. Do a little cross check. Cross check is what we do on airplanes. Did you know that? Cross check. Everyone checks their answer, even airplanes. All right, x equals 3. On one side, I get 3. Does that equal, question mark, what I get on this side? Put a 3 in here. That's 3 plus 6 is 9 to the 1/2 power. That's the square root of 9, which equals 3. We're good to go. So that is good to take off. What about x equals negative 2? So I have negative 2 on this side equals, or does it? That's the question. What I get when I plug in negative 2 here, that's negative 2 plus 6 is going to be 4 to the 1/2 power, which is the square root of 4, which equals 2. Does negative 2 equal 2? No, no. They're not equal, and so in fact, this is an extraneous solution. This actually is not right. And again, we see another example where by squaring both sides of an equation, we've accidentally introduced a solution that really is not a solution. Solution to this is x equals 3.
The last part that we're going to study here in this lesson, the radical inequality. A radical inequality is an equality that contains a variable within a radical. You can solve a radical inequality by graphing or by using algebra. Okay, the first method is you're going to use it to answer it using the graphing calculator, and the second part is by using algebra. Remember here, a radical expression with an even index and a negative radicand has no real roots. Just to remember. Okay, use algebra to solve the inequality. Solve for x. Okay. Square root of 2x plus 4 is less than or equal to 4. Square both sides. The same. All the steps are repeating themselves. Okay. Square roots, so I will raise them to the power of 2. So 2x plus 4 is equal to 16 because 4 to the power 2 is 16. Subtract 4 from both sides. 2x is less than or equal to 12. So x is less than or equal to 6. Consider the radicand. 2x plus 4 is greater than or equal to 0. The radicand cannot be negative. Solve for x. 2x, subtract negative 4 from both sides. So x is greater than or equal to negative 4. So the solution of square root of 2x plus 4 less than or equal to 4 is x negative 2. X is greater than or equal to negative 2, and x is less than or equal to 6, or x is greater than or equal to negative 2 and less than or equal to 6. Okay.
Let's take a look at an inequality that involves a square root. Square root of the quantity 2x plus 6 is less than or equal to 4. This actually is going to require us to think a little bit harder than usual. So let's think through this. The first thing is we don't know what x is. But plainly, whatever it is, for this to even make sense, that stuff inside that radical has to be positive, right? It has to be positive, because if you picked an x that made that negative, you couldn't even take the square root of it. So automatically, I know that that stuff down here has to be greater than or equal to 0. Okay, that's the first thing. Now, armed with that, what I'd like to do is to square both sides. I've got a positive number on this side, I got a positive number on this side, so I can square both sides of this inequality without harming it at all. So I've got this, and since everybody's positive, I'm just going to square this side, square this side. The inequality symbol stays the way it is because of the scenario, and now the radical will lift, and so I'm left with this less than or equal to 16. But I'm not done, because remember what we said just a few moments ago. What's the other condition we have to enforce? We have to make sure we're not accidentally taking the square root of a negative number. So the stuff inside the square root, which is right here, that has to be greater than or equal to 0. So I'm actually going to introduce that right here. So here you can see this sort of string of inequalities, and they all have to be satisfied at once. Okay, now let's solve this. So the way to solve this is to first isolate the x. So let's now subtract 6 everywhere. So here I see negative 6 less than or equal to 2x less than or equal to 10. And now I'm going to divide everything through by 2. Now 2 is a positive number, so the inequality symbol does not reverse. And here I see negative 3 less than or equal to x less than or equal to 5. And that's the answer. So it's all the x's that are between negative 3 and 5, including both negative 3 and 5. And we arrived at that by squaring both sides of this, getting this inequality, but then remembering that the stuff inside there has to be positive. That gives us this inequality, and we put them together. Now, you could actually check your answer using a graphing calculator. So the way you would actually do this is you could do it 2 ways, and let me just tell you both ways. One way is to actually graph these 2 functions. Really? The 2 functions? Sure. Call y1 the square root of 2x plus 6, and then let y2 equal the constant function 4. And now look at the graphs, and the question is, when is y1 below or equal to y2? And if you check it out, you can see that little teeny range in there where, in fact, y1 is dipping below y2, and you can see that it seems to indicate, at least on that graph, that it's exactly between negative 3 and 5, just as we predicted. So that's awesome. The other thing you can do, by the way, is go to the table function. You can actually make a table of values both for y1, the y1 function, and the y2 function for various x values. And there again, you can see, if you look at that table, you can see when do we see the y1 values less than or equal to the y2 values. They're exactly in the range negative 3 to 5. So again, we can confirm that with the graphing calculator, either using the table or using the graph to visualize it, or just plain old careful algebra, but really careful here, because you want to make sure that you see there's an implicit extra inequality hidden, lurking behind the scenes.
Okay, thank you so much, girls, for listening. I hope you will answer your homework and see you on Sunday. Thank you so much.